Hello, this is Shriptapal from Bangladesh, and welcome to AeroLab, my CS50P final project. It is an advanced flight dynamics simulator that I built from scratch using Python, Streamlit, NumPy, SciPy, and Plotly. But instead of just talking about it, let me show how it works. When I run a simulation, my physics engine calculates the entire path in 3D and generates a massive real-time data report. Now, let's walk through the setup process of our mission parameters in the sidebar. Under Mode, AeroLab offers two options: targeting and simulation. Simulation analyzes the flight based on our inputs, though random data usually results in a failed launch. Targeting, however, calculates the exact parameters needed for a perfect hit. Starting in the location settings, we pick a country and division, province, or state. This fetches the average temperature and pressure for advanced buoyancy calculations. It also fetches latitude and elevation to determine local gravity. Next, under Projectile, we configure the mass, shape, geometrical specifications, and flight orientation. Moving down, we input the platform height and platform velocity. In the spin section, defining the spin type and RPM lets us see the Magnus effect in the action. We then set the wind velocity. Finally, under target, we input the distance from launch, height from ground, and target velocity. Let's hit calculate. Our robust validation system just got some invalid inputs. Let's fix them, ignore the warnings, and view the results. With the sidebar collapsed, we get a clear view of the mission dashboard. At the top, our targeting status confirms target neutralized, with the hit level and the phase. Just below that, we can view any ignored system warnings and physics engine alerts. Moving down, we see a location, environment data, and the closest distance. We also get the exact coordinates under projectile closest position and target closest position. Right beside our 3D trajectory graph is the projectile specifications. Also, there are flight duration, projectile range, arc length, max height, and the time of max height. Scrolling down to initial kinematics, we find the projectile launch velocity, the exact launch information precisely calculated by our physics engine. Alongside this, we see the projectile launch position, target initial velocity, and target initial position. Next, impact kinematics displays the exact projectile impact velocity, projectile impact position, target final velocity, and target final position. The energy profile analyzes the flight's efficiency, initial energy, final energy, drag work, and a complete loss breakdown. Under environment and ranges, we track the exact fluctuations across the drag range, Magnus range, gravity range, buoyancy range, and air density range. Below that, there is the detailed G-force analysis. Next, impact forces and acceleration details the impact net force, impact drag, impact Magnus, and impact acceleration. Finally, at the very bottom, we can open the physics engine response to view detailed JSON data used to render this entire dashboard. And that wraps up the complete breakdown of the AeroLab dashboard. I'm a high school graduate applying for a computer science undergraduate degree. Building this physics engine took over 2 months for me and pushed my coding skills to the absolute limit. Thank you for watching. This was CS50P.